welcome back, everybody. We're continuing on with our data analysis and discussing box and whisker plots today. If you would pause the video and jot down these vocabs. All right, before we get into this example one, I'm going to give you a couple of steps that I'd like us to jot down to help us find these. So first, we're going to put the data in order from least to greatest. Once we've done that, we will split our data in half, which find the median. From that median, you're going to find half of each half, which is basically finding the median of those two sections. And again, that'll make a little bit more sense once we do that. I also gave you a table here that might help us with getting all the information that we need. So the 5-number summary is going to be our least value, our greatest value, the median, first quartile, and second quartile. That's our 5-number summary. The other two things are just kind of more helpful for when we're determining graphs and things like that. All right, so let's get started on this one. I'm going to start with putting our data in order from least to greatest. We have 18, 22, 22, 24, 25, 25, 25, 27, 28, 30, 30, and 30. All right, I see 3 25s and 3 30s. So if I were looking at the mode of this, which I'm not, but if I were, then I would say our mode for this one would be 25 and 30. Remember, your mode can be more than one number. If there's more than one number that appears the same amount of times in the data set. We have 12 values in our data set. Our least value is 18. Our greatest value is 30. That gives us a range of 12. We have 30 minus 18 gives us 12. For the median, we got to come to the middle. So 1, 2, 3, 4, 5, 6. And so 6 and 7, halfway in between is our median. Halfway between 25 and 25 is just 25 because they're the same number. For our first quartile, we go through this right half and we find halfway again. Now there's 1, 2, 3, 4, 5, 6 values in that half. So we're in between 22 and 24. Halfway between 22 and 24 is 23. And again, you could find that from doing 22 plus 24 divided by 2. So that's our first quartile, or the first quarter of our values. The third quartile comes from the right side. Again, there's 6 values here. 28 and 30 are the two middle values. We find the median of that for our third quartile value. Halfway between 28 and 30 is 29. And again, we can calculate that 28 plus 30 divided by 2. These 5 values right here are the values that we need to be able to make our box and whisker plot. I'm going to erase a little bit here so we have some space. We're going to start with making a number line. So my number line, and And I need at least, because we have 12 values as our range, so I need at least 12 lines here. So I'm going to make 18 is my least value. And I'm going by ones, but I'm going to write just every other one. Save some space on here. 28, 30, 32. All right. I'm going to start with a dot at my least value and a dot at my greatest value, starting and stopping. Our median is 25, so I'm going to put a line at 25. Our first quartile is at 23, and our third quartile is at 29. Those 3 lines make our 2 boxes. And then we have our whiskers on either side going to those 2, what I will call them endpoints for right now, of our graph. And that's our box and whisker plot. Let's try another one. I'm again going to start with putting our values in order from least to greatest. We have 12, 13, 15, 16, 18, 18, 20, and 24. So if I count the number of values I have in our set, we have 8 values. Our least value is 12. Our greatest value is 24. 24 minus 12 gives us a range of 12 total. That needs to be on our number line. Our median halfway is going to be between 4 and 5 because we have an even number of data values. So there's my split in half. We have 16 plus 18 divided by 2, which is 17. This is our first quartile over here on the left side. The middle term is going to be in between 13 and 15, which is 14. And again, you can find that by doing 13 plus 15 divided by 2. And our third quartile range comes on the right side between 18 and 20, which halfway between 18 and 20 is 19. Again, 20 plus 18 divided by 2. That math can get you the answer. And so we have our 5 number summary right here. That's going to allow us to make our graph. Make your number line. So let's see, I'll start 12. And again, I'm going by ones, but I'm just writing every other one to save space here. All right. So I'm going to plot 12 and our greatest number 24. I'm going to mark my median at 17, our first quartile at 14, and our third quartile at 19. Connect those lines for our box part, and then drag out those whiskers, and there's our box and whisker plot. Please give the next you try a shot. Bring that into class, and we will go over that and continue from there. All right, so interpreting box and whisker plots. 1/4 or 25% of the data is actually in each piece of this. So while the range of the data in each piece are not the same, the amount of data in each piece is the same. So the same amount of data points in each piece. So this is a measure of the spread of the data in each quartile, or 25% of the data that we've graphed. So if I'm looking here at this box and whisker plot, let's start with the range. So our range goes from 160 to 300. And that difference is 140 seconds. So there's 140 seconds difference between the shortest and the longest playing song of the band at this particular concert. The distribution of the data. Well, we have 25% of songs that they play range between 160 seconds to 220 seconds. Half, or 50%, of the songs that they're playing at this concert are between 220 and 280 seconds long, and 25% of songs are between 280 seconds and 300 seconds long. So that's part B. Interquartile range. So that range is the middle 50%. It's the box part. So IQR is the box part. That middle 50%. We have 280 minus 220 is 60 seconds. So the middle half of the songs have a spread of 60 seconds, or there's a maximum of 60 seconds difference, or 1 minute, between the middle length songs that they're playing. Are the data more spread out between quartile 1 or quartile 3 above? Well, if we look at below Q1, that's the left whisker. It goes from 160 to 220, which is a 60-second difference. Above Q3, which is the right whisker, we're going from 280 to 300, which is a difference of 20 seconds. So which one has the bigger spread? Well, it's below quadrant 1, because the difference in range from start to finish is 60 versus 20 for the upper. Sometimes it's helpful to fill in our data set. And so I'm going to go ahead and do that on here to help me answer these questions. My least value according to this data set is 1. My greatest value is 9, because that's over here at the end. Our median is this line in the middle, and that matches up to 5. Our first quartile, the start of our box, is right here at 3. Our third quartile, or the end of that box, is at 8. The range from start to finish is from 9 to 1. Oops, let me change that color so we can see it. 9 minus 1, which is going to be 8. And our IQR, remember, goes from the start of our box to the end of our box. And that's 3 to 8. 8 minus 3 is 5. Now, we can't tell the data set. We don't know exactly how many values are in there because they didn't give us a table or anything. So we can't make any assumptions about how many data points are in there. All that we know is that this whisker is 25%, this part of the box is 25%, this part is 25%, and this last whisker is 25%. So if we're interpreting the range, then we have the range is 8. So groups spent no more than 8 hours difference on that project. The distribution of the data. So 25% spent between 1 hour and 3 hours. 50% spent between 3 hours and 8 hours. And then 25% of the students spent between 8 hours and 9 hours on this project. The IQR is 5. Okay, we found that down here. That means the middle half of time spent varied by about 5 hours. And then it's again asking us about the spread of the data. So if I'm looking at the spread of the data between the left whisker and the right whisker, then we have our left whisker, which is below Q1, is 3 minus 1, which is a 2-hour spread. Our right whisker, which is above quartile 3, is from 8 to 9 hours, and that's only a 1-hour difference. So again, the left whisker has the longest spread. Pause the video and jot in these comparisons. So let's take a look. We have test scores for our class and our friend's class. Our right whisker here, we're not sure exactly where this is. We're going to say maybe this is 68 to 85. And that's going to give us a difference of about 17 on that whisker. And then 95 to 100, which is 5. For our friend's class, our left whisker, 60 to 70, is 10, and 90 to 100 is 10. So we can clearly see not only from just the shape and length of the whiskers visually, but also by the numbers, that our class is skewed left and our friend's class is symmetrical. Which test scores are more spread out? Well, now this deals with range. And so which box and whisker plot is the longest? Well, that's the friend's class, the red one. The red one goes from 60 to 100, which is a difference of 40. And our class goes from about 68 to 100, which is 32. So the friends class is more spread out because the range is larger. So we're looking at kicker A and kicker B. Visually, we can see that kicker A, remember, we're not looking at the box part, we're looking at the whisker parts. Kicker A is skewed right because the whisker on the right is longer. You can also, again, verify this with looking at the length of it. 32 to 36 is 4, versus here we have 24 to 26 is 2. If I look at kicker B, then we have kicker B, 22 to 24 is 2, and 29 to 31 is 2. So kicker B is symmetrical. Which length or which value is more spread out? Well, again, we would find the range. So if I'm looking at the range of kicker A, we're going from 24 to 36, which is a difference of 12. And for kicker B, we're going from 22 to 31, which is a distance of 9. And so kicker A would have the larger spread. That's where we are going to end for today. Thanks so much again for joining me. Have a great rest of your night.